अब स्टूडेंट्स टाइप्स ऑफ एरर्स को हमने स्टडी किया था. Another concept in the process of error detection and correction is the redundancy. Students, what we do at the sending end when we are trying to employ a error correction or error detection technique, what we're doing is we are actually adding redundancy. We are adding some redundant bits in our data. Students, at the receiving end, the presence of these redundant bits that signals to the receivers whether there is an error that's present in the data or not. Students, अब आगे चल के देखेंगे when we'll start the discussion of our coding schemes or the encoding mechanisms, you'll see that the redundant bits or the addition of these redundant bits is a major tool or is a major function that we deploy whenever we are employing a particular error detection or a correction technique. Students, next topic is just a little bit about error detection versus error correction. Students, error detection is simple. Error correction is complex. And the reason I say that is because in the process of error detection, all that you need to know is whether an error has occurred or not. So you need to find a mechanism for error detection that at the receiving end can tell you if the error has occurred or not. We are not concerned with how many bits are impacted. We are not concerned with which bits are impacted or what is the location of the error. All that we need to know is a yes or a no to the question of whether the error has occurred or not. Students, you'll see in the further discussions that this type of an error detection without any mechanism for error correction is normally employed in the cases where the only way for us to fix an error is to employ a retransmission. इस case में when the only way for us to fix the error is to ask the sender to send the message again, what we do is we normally deploy enough mechanism to just allow us to do the error detection. Correction is normally not done. So students, in this particular case, we have got a simple or a simpler task at hand as compared to error correction. Now, students, in the case of error correction, there are a few factors that the error correction depends on. It depends on how robust your transmission medium or your link is. It depends on how long your message is. So in other words, just to summarize, error correction will need the exact number of bits that are corrupted, because we need to fix the bits that are impacted. We need to know what are the exact bits that are corrupted. Students, secondly, we need to find out their exact location in the message. And what I mean by that is, when you look at an 8-bit message, जब हम लोग types of errors को study कर रहे थे, I gave you an example of a byte that got corrupted, both in the case of single bit error and also in the case of a burst error. In the case of burst error, we also saw that our burst was 8 bits or a byte long. Students, if you have to find a particular location of an error in these 8 bits or a byte, you need to check 8 different locations, 8 different possible locations for the existence of this error. Students, गौर कीजिएगा, if we are now looking for 2 errors, that was a single bit error. If you are looking for 2 errors in 8 bits, in that particular case, we are looking for 28 different combinations. And this goes on. Students, just consider what would it be like if we need to find, for example, 100 errors in about 1,000 bits, or 5 errors or 10 errors in about 1,000 bits. Task is humongous. The correcting mechanism needs to be very sophisticated, and it needs to make sure that the exact location of these bits, it is known to the receiver. And not only that, the correction mechanism is in place so that it can go, it can find that location, it can fix those errors as well.